Hi, so this is the second video of probability. In the last video, what we concluded was we learned two things, that is experimental probability and theoretical probability. Experimental probability we will get when we perform the experiment several times. How many ever times we perform the experiment, that is called the total number of trials, and the number of times in the experiment when the event happened will be the numerator, so that will be probability of that event. For example, we took a coin toss and we have tossed it 10 times, and if heads has come 3 times, then the event of getting a heads, the probability will be 3 divided by 10. And then we came with theoretical probability. What theoretical probability? Before instead of performing the experiment, before only we see what are the possible outcomes. So if we toss a coin, the possible outcomes are only heads or tails. So we write down all the possible outcomes, like in the bracket, all the possible outcomes we write down, and then whenever there is an event, we will write down whether from this, if that event is satisfying, if that outcome is satisfying the event, we write down all those events. How many ever number comes here, that divided by total number will be the probability of that event. So this is how theoretical probability works. Now one more thing that I have to tell you is, what is the relationship between experimental probability and theoretical probability? What is the problem with experimental probability is we don't know how many times to perform the experiment. But it turns out that if we increase the number of trials to infinity, that is, infinity means technically it should never end. Okay, but even if you don't, if you do like many times, if like 1 crore times or something like that, then experimental probability will become close to theoretical probability. So for example, with the coin toss, what was the theoretical probability of heads? It was 1 by 2. Wait, let me write that down. So theoretical probability was 1 by 2. Okay, experimental probability, we got several things. If we do it only 5 times, we got one person got one thing, another person got another thing. Why we are not getting 1 by 2 is because if you perform the experiment infinity times, then only you will get the experimental probability equal to theoretical probability. So for example, 1 by 2 is how much? 0.5. 0. And here experimental probability, if you perform it 10,000 times, then it might become 0.48. Okay, if you perform it 100,000 times, it might become 0.49 or 485. Similarly, if you do it 100,000 over, no, then 10 lakhs, 100 lakhs, 100 lakhs is 1 crore. So if you keep on going like this only, then eventually 0.5, that is technically when you become infinity, it will become 0.5. But if you keep on doing this more and more and more, it will become closer and closer and closer to 0.5. Okay, so you can never reach 0.5 when you're doing experimental, probably when you're doing experiments. So if you perform the experiment infinity times, only then it will be equal. Okay, that's why we use theoretical probability, because we can't do any experiment infinity times. Let's go to the next slide. What are the bounds of probability? So what are the bounds? Bounds means the probability can only be between 0 and 1. It can be 0, it can be 1, or it can be any number between 0 and 1, but it can never ever be greater than 1, or it can never ever be less than 0. So in your question, sorry, if you're writing the answer, if you get the probability as less than 0 or more than 1, then it is a wrong answer. You can immediately know that it is wrong answer. You will get 0 marks for that. Okay, so minimum probability is 0. So if for an event a P of E is 0, then what does that mean? It means that the event is an impossible event. Impossible because the probability is 0. If probability is 0, it means there is 0 chance of that event happening. So if we take an example, it will be probability of getting a number greater than 6 when a die is thrown once is an impossible event. So if you throw the dice which has 1 2 3 4 5 6 on it, then it is impossible to get a number which is greater than 6. So this is an example of an impossible event, and for this probability will be 0. Maximum probability is 1. So what is 1? If for an event the probability is 1, then the event is known as a sure or a definite event. Means it will definitely happen. Okay. So for example, the event getting a natural number from 1 to 6 when a die is thrown once is a sure event. So when you throw the dice, it is definitely sure, we are perfectly sure that whatever number comes up on the dice will be from 1 to 6. So that is a sure event. Okay, so these are the bounds of probability. Now let us look at some probabilities of elementary events. Okay, what is elementary event? It means we are looking at here all the outcomes of the experiment we are looking at for the dice roll. Now what is the probability of each outcome of the experiment that we want to see? Okay, elementary events means like for example, if I tell the probability of a dice getting a 1, that is we are referring to only one outcome. Okay, one outcome, then that is called an elementary event. That is when we are taking only one outcome. But if we take for example probability of getting even number means it will become 2 4 6. It is three outcomes we are considering in one thing only, so that is not an elementary event. So elementary event is an event which we write this in the brackets, right? What we write for every event, we write down this brackets and we write from here whichever is possible. So if for that event only one outcome from here is possible, then it is called as elementary event. Okay, so let us see, let us take one. This is an elementary event, that is probability that dice will get 1. What is the probability? Total number of cases is 6. Number of elements in this is 1 because we have taken only one. It is an elementary event. What is the event? Event is getting a 1 when dice is thrown. Understood? Now we have done this in the previous video also. So probability of getting a 1 when the dice is thrown is an elementary event. Why? Because it has only one outcome, okay, in its event brackets. Now the probability is 1 by 6. What will be the probability of the event getting a 2? Again let us write down the favorable cases, 2 only. So the probability here again is, how many are there? 1. So total number of favorable cases is 1. Total number of cases will be again same 6. So here in the dice we are seeing that each elementary event will have probability as 1 by 6. So what is the sum of probabilities of all these? So 1 by 6 plus, this is, for this it is 1 by 6. For 2 again it is 1 by 6 plus 3 again 1 by 6. So for all the events we have written here for 1 2 3 4 5 6, these are all the possible outcomes. So for all the possible outcomes we have written the probability. If we add them, what will happen? The denominator is same 6, so we can add the numerators. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 6. So 6 by 6 is 1. So this is a sure event. So sum of probabilities of all the elements is 1. Similarly, it has do for coin toss. All possible outcomes is H and T, that is heads and tails. Each elementary events can be what? H and T individually. So of this event, when only heads comes, that is, what is the probability? We saw that the probability is number of favorable cases, that is 1 divided by total number of cases, that is 2. Okay, 1 by 2. What is the probability of the next elementary event, that is tail? That is again 1 by 2, because number of favorable cases is again 1 divided by total number of cases is 2. Now sum of probabilities, let us do again. So 1 by 2 for heads plus next outcome is 1 by 2. So 1 by 2 for tails. So total will be what? 1 by 2 plus 1 by 2 is again 1. So we saw both the cases. When we add up the probabilities of all the outcomes, it will become 1. Let us see why. Okay. So what does it mean when we take the sum? So what it means is, when you take sum of two probabilities of two independent events, it means saying event 1 will happen or event 2 will happen. Understood? If we add the probabilities of event 1 and event 2, then it means we are saying either event 1 will happen or event 2 will happen. Okay, let us see an example, we'll understand better. If we add the probabilities of two events for this experiment, that is dice thrown once is the experiment. What are the two events we are adding? We are adding event 1 is 1 comes on the dice, event 2 is 2 comes on the dice. Okay, we know the probabilities of both the events. 1 comes on the dice is 1 by 6, 2 comes on the dice is also 1 by 6. Now if we add these two, we will get 1 by 6 plus 1 by 6 equal to 1 by 3. So when we are adding, what does it mean? We are saying that either event 1 will happen or event 2 will happen. That is, here either 1 will come on the dice or 2 will come on the dice. So what will this 1 by 3 be? That is sum. It will be the probability of event 3 is equal to 1 or 2 comes on the dice. So 1 will come on the dice or 2 will come on the dice. Understood, no? So here what happened, when we added the events of all of them, what it means is either 1 will come or 2 will come or 3 will come or 4 will come or 5 will come or 6 will come on the dice, is what the event when we add all of them. So of course when we throw a dice, any of these numbers has to come. So that's why when we added all the probabilities, it became 1, because it was a sure event. Either of all these cases has to come. Here also, here all the outcomes are this, so either this or this has to come. So when we added both of this, it came either heads or tails, and because that is the only possible outcomes, again it is a sure event, because we are sure that when we toss a coin, either heads will come or tails will come. Correct, no? So that's why the again probability we got as 1. So this you have to understand. Whenever we write this as all possible outcomes of the experiment, when we add all these individual elementary events for each outcome, it will become 1. Okay, now let us look at one more concept, that is complementary events. Okay, so if for two events E1 and E2, probability of E1 plus probability of E2 is 1, then E1 and E2 are known as complementary events. Okay, so let us see an example again, you will understand better. For an event E, the event not E is denoted by E bar, okay, whose probability is denoted by this one. Let us see what this means. First of all, I told you that E1 and E2 are the two events of one experiment, such that probability of E1 plus probability of E2 is 1, then E1 and E2 are known as complementary events. So for an event E, what will be the complementary event? If the event E has to happen, the probability is something. If it does not happen, then it is not E. That is the complementary. Let me show you the example. Okay, let us say, let me write again. Okay, so let us say event E is getting 1 on the dice. Okay, so this is E. Okay, that is, wait, if for an experiment die is thrown once, event E is getting a 1, then probability of E is 1 by 6. Then E bar, that is complementary event of E, would be what? Not E, right? So not E means not getting a 1, right? So if the experiment is, if the event is getting a 1, complementary event would be not getting a 1. The probability of this will be what? It will be 1 minus 1, 1 minus probability of this, because when we add probability of an event and its complement, it should be 1. So if this is 1 by 6, then not of that event would be E bar. So E probability of E bar will be 1 minus probability of E. So that's why we will get this. First of all, what does this mean? Why is it sure event? Of course it has to be sure event, because if an event, probability of event is there, okay, and then if that event does not happen, okay, let me, I can rephrase. If for example probability of E is P of E, that we say 40% of the time probably this will happen. 40% of the time means probability will be 0.4. Okay, then what will happen the rest of the time? Remaining time it will not happen, right? So then if we add the probability of it not happening, then it has to become 1, because there are only two possibilities. The event can happen or not happen, right? It cannot happen and not happen at the same time. So if the event happens, we have told the probability is 0.4. Then it is assumed that the probability of the event not happening is 1 minus 0.4, that is 0.6. Okay, so this is a very easy rule, because we know that if probability is 1 means it is sure event. So if probability of an event is something, then probability of that event not happening will be 1 minus that thing. Okay, so this we use several problems. Let us see some problems. Okay,
Okay, so now let's look at some problems. Okay, so I want you to open your textbooks, maths textbooks. Open page number 116. Okay, and yeah, it is, we're going to look at example 4. Example 4. Okay, so let us see. What is the question? One card is drawn from a well shuffled deck of 52 cards. So I have explained to you what is the deck of cards. How many cards are there? 52. Okay, so what is the experiment here? Experiment is one card is drawn from 52 cards. That is the experiment. Now they are asking questions. So first one is, what is the probability that the card is an ace? So this is the event. Now we have to write all the favorable cases. So all the favorable, sorry, first of all possible outcomes. We have to always write this for experiments. All possible outcomes is equals to, we start writing all the possible outcomes of this experiment. That is, one card is drawn. So one card is drawn from a deck of 52 cards, means what are the possible outcomes? It could be spade S, spade 2, spade 3, so on up to spade king. Similarly, it could be Collover ace, Collover 2 up to Collover king, like that only it can be all the 52 cards. So there are 52 possibilities. Okay, there are 52 possibilities. This is the all possible outcomes. Now favorable outcomes for this event. So favorable outcomes are we start a bracket and we write down the one by one. We will start all the possible outcomes we will put and see whether it matches the event. So it has to be an ace. So it can be a spade ace. Spade ace will fit, it is an ace. Spade 2 it won't fit because it is not an ace. Similarly Collover ace will fit. What are the other aces are there? Heart ace is there, and then diamond ace is there. So these are the four possibilities. That is favorable outcomes. So what will be the probability of this event? P of E is number of favorable outcomes by number of total outcomes. Favorable is 1 2 3 4. 4 divided by 52. Okay, so this is the so if we cancel it will become 1 by 13 will be the answer. Okay, now this is for the event an ace. Okay, now what is the second part? The second part is asking you the probability that it is not an ace. So for this you can do it in two ways now. So just like normal, we could also start writing the bracket, and we could write down all the favorable cases. So favorable cases, again we will draw a bracket, and from all possible outcomes we will start writing one by one. It should not be an ace. So spade ace won't work, Collover ace won't work, heart ace won't work, and diamond ace won't work. But remaining 48 cards will work, no? Starting from spade 2 up to spade king and all of them. So all the 48 cards, that is 52 cards minus these 4 ace cards, everything will work. Those will be the favorable cases. Now what is the probability then? Number of favorable cases by total number of cases. So that will be 48 by 52. That is 2 24s are 2 26s are 2 12s are 2 13s are. So 12 by 13. So this is the answer we got in this method. Now what else we could do? We could also, I have explained to you the probability of not an event. If probability of E is something, then probability of not E is 1 minus x. That is 1 minus probability of E. So here E, if we take as S, so E is getting an S. No, we want not an S, so we want not E. So how much we got E? We got 4 by 52, no, that is 1 by 13 we had got for the first one. 1 by 13. This is for the first question. Then we want not E, because the second question is not an S. So not E means not E. So probability of not E is equals to probability of not an S is equals to 1 minus 1 by 13, because it is 1 minus E, probability of E. So 1 minus 1 by 13 is how much? Take LCM. It will become 30 into 13 into 13. 13 minus 1 by 13 is 12 by 13. So this is what we got here also. So both the methods will work, but this is more easy because you can just do 1 minus this instead of writing all the cases. So this is how you use the complementary events part. Okay, so let's move on to the next question. Okay, let's move on to the next question. So this question is about Savita and Hamida. See, we are going to example 6. Open that in your textbook. About Savita and Hamida. What is the question? Savita and Hamida are friends, what is the probability that both will have different birthdays? So let's calculate that. How to calculate this? Usually we used to do first all possible outcomes of the experiment. Now for Savita, how many if we are finding the birthday of Savita, what are the possible outcomes? It can be Jan 1st, Jan 2nd, or up to December 31st. So how many are there totally? 365, because there are 365 days in a year, because in the question if you observe they have asked us to ignore the leap year. Leap year, it has 366 days. Okay, but they have asked us to ignore it, so we have 365 days. Hamida, how many? Hamida also again same thing, 365 outcomes are there. These are all the outcomes for Savitra and Hamida's birthday. Now we want only those outcomes in which Hamida's birthday is different from Savita's. So what is the event? The event is Hamida's birthday is different from Savita. Correct, no? So now what are the all possible outcomes of Hamida's birthday? It is Jan 1st to December 31st. So 365 outcomes are there. Okay. Now Savita's birthday is on some random day. Let us say it is on some day. So it is one on one day only. No, a person can have a birthday only on one day. So all possible outcomes for Hamida's birthday is 365. So probability of event is Hamida has a different birthday than Savita. So all possible outcomes are 365, because on any day of the year Hamida can have her birthday. But number of favorable outcomes. What are the number of favorable outcomes? It is any day other than Savita's birthday. So all the days other than the Savita's birthdays will be the favorable cases. Favorable cases will be all the days. So Jan 1st we can write, Jan 2nd we cannot write because Jan 2nd is Savita's birthday. Similarly we will write all the days, but like it need not be on Jan 2nd, but I'm telling it can be any day. Whatever day it is, that day we cannot put it in here. So how many are remaining? All 360, all the year days we can put except for one day. So how many we got? 364 favorable cases. So Hamida can have birthday on all these 364 days other than one day. So that is 364 favorable cases. So probability that Hamida will have a birthday different than Savita is 364 by 365. Okay, this is slightly difficult than the normal thing. In normal thing, the dice and all was so easy because it was easy to write all the outcomes. But this problem you have to think a little bit. Okay, so in this problem you have to see what are the possible outcomes for Savita, what are the outcomes for Hamida's birthday. Now what are the outcomes for Hamida's birthday when it is different from Savita's birthday? So then we get the answer. Now what is the second question? It is same birthday. Is this opposite of first question? Yes. So this event can be written as not of different birthdays. Right? Not of different birthdays. So we already got the probability for first one, that is 364 by 365. Now probability of not of that event will be 1 minus P of E. Will be P of not E. Correct, no? P of not E will be 1 minus P of E. What is not E? That is not a different birthday, that is same birthday, is 1 minus P of E. So is equals to 1 minus 364 by 365 is equal to how much it will become? 365 minus 364 by 365. So it will become 1 by 365. Okay. So this question is little difficult. You have to understand how to do it. Let's move on to the next one.